Okay, so good day everyone. I am Arambulo Franco Miguel from BS IT3A and will be presenting my midterm video for this subject. So, so we're tasked to discuss and talk about four topics. First is about tangible and intangible platforms and its role to modern computer systems. Second is management of secondary storage and its main activities in the operating system. Third, the OSI model and its 7 layers. And lastly, is to explain what network platform is. So let's proceed. So modern computer system. Before heading to the first objective, I want to give a brief explanation regarding modern computer systems. So what is a modern computer system? It is simply the computers that we are currently utilizing, from our simple and basic daily needs to high processing calculations and functions that are able to address wider scale issues in each sector such as economy, science, society, and etc. There are certain characteristics for it to be considered a modern computer. It factors its speed, accuracy, storage, automatic functioning, user-friendly, and entertainment, to name a few. Hence, example of these are supercomputers, the internet, and even our personal computers and laptops are considered modern computer systems, as the characteristics mentioned are observable to these kinds of computers. So, what is tangible and intangible platforms? And what its relation to the modern computer systems? So, so tangible, tangible by definition is basically the things the user are able to touch and interact with. And as a platform, it is the tangible objects interfaced with computers, meaning a set of hardware on which software applications can be run. The keyword here is hardware, and the hardware is built to house the software processes. As an example, the first image is a case of a typical desktop PC, wherein it has a power supply, motherboard, the ports, and processor. All these are hardware that our user is capable of interacting with. They can they can upgrade it or change it, whatever they want. Another is a diagram of major PC components. These are the needed components in order to build a well-functioning computers. So the similarities of these two, both these diagrams simply shows the physical components what a modern computer system needs. On the other hand, intangible platforms is primarily the opposite of tangible. These are the factors the user has no control with. By definition, it is the software environment that is used to write applications and run them. This is where the creation of applications begins. And as a intangible platform, users can't access this unless they are developers who are creating and writing these applications. These in-progress applications can be run through these types of platforms that are shown in the picture on the right, depending on its usage. It can be used in a mobile device platform, computing platform, network communication platform, and so on. Example of these intangible software platforms are graphic user builders or GUI, compilers, class libraries, and utilities for developing applications. So the question here is, what are their role in modern computer systems? To put it simply, the tangible and intangible platforms is what makes the modern computer systems. They work hand in hand in creating and improving our existing modern computer systems. Ergo, a simple upgrade in a hardware capacity can improve the computer's performance, or the newly created applications can be used to communicate properly and make ease on our daily lives. Um, to in comparison to reality, for me to make it clearer, Tangible and intangible platforms are the parents, and the offspring is the modern computer system. So that's as simple as that. So next, moving on, the next topic, the second objective is management of secondary storage. First, let me explain what is secondary storage is. So secondary storage is the non-volatile respiratory for data and programs. And as a part of an operating system, the file system manages this information on secondary storage. These are also located in the devices where data is stored for a long-term storage. It is anything outside the primary storage. Uses of secondary storage include storing various forms of programs and temporary storage of virtual memory pages. Example of these storage devices are secondary storage devices are solid state drives or SSDs, hard drives, flash drives, SD cards, and etc. So these secondary storage devices are the newer storage devices as of now. Unlike before that we use compact discs which is low in capacity and cheaper and hassle. And now we have more faster and better secondary storages. So next slide. So management of secondary storage. In a computer system, secondary storage management is important as one of the system's main function. Its main activities are the following. So first is mounting and unmounting. Mounting is a process by which the operating system makes files and directories on a storage device available for users to access via computer's file system. On the other hand, unmounting, it is the opposite process of mounting, in which the operating system cuts off all user access to files and directories on the mount point and undergoes a process making a storage device safe for removal. Basically, both these are it's the attachment and removal of the storage device to the computer, and it's that simple. So next is free space management. The system keeps tracks of the free disk blocks for allocating space to files when they are created. Also, to reuse the space released from deleting the files, free space management because crucial. The system maintains a free space list which keeps track of the disk blocks that are not allocated to some file or directory. To put it simply, it is the process of looking after and managing the free blocks of the disk. Also, there are techniques and methods in doing so are the following: bitmap, linked list, grouping, counting. So the third is disk scheduling. Ay, storage allocation rather, I'm sorry. So third is storage allocation, and according to Oxford Dictionary of Computing, it is the act of allocating storage to a process. In a multi-programming system, it is necessary to control the use of storage to ensure the process do not interfere with one another's workspace, except where they do not intentionally in order to cooperate. These represent one instance of the resource control activities within the system. There are different ways to allocate a memory. These are static storage allocation, stack storage allocation, and heap storage allocation. So next is the disk scheduling. So disk scheduling and the definition given from Geeks for Geeks is this scheduling is done by operating systems to schedule input-output requests arriving for the disk. This scheduling is also known as input-output scheduling. There are several disk scheduling algorithms. Some few are CFS or first come first serve, LIFO or last in first out, SSTF or shortest seek time first, and look and scan. And there are more algorithms from this scheduling. Next is partitioning. It is a section of a storage device such as hard disk drive or solid state drive. It is treated by operating system as a separate logical volume, which makes it function similar to separate physical device. So further description in partitioning, it is a disk can make it easier to organize files such as video and photo libraries, especially if you have a large hard drive. Creating a separate partition for your system files can also help protect system data from corruption, since each partition has its own file system. For many years, it was advisable to partition hard drives to reduce the minimum sector size and increase performance. However, with modern file systems and faster HDDs and SSDs, creating multiple partition no longer has the same benefit. So, lastly, in this topic is protection. So these are the main goals of protection. So first is to prevent malicious misuse of the system by users or programs. Next is to ensure that each shared resource is used only in accordance with system policies, which may be set either by system designers or by system administrators. Third is to ensure that errant programs cause the minimal amount of damage possible. Protection systems only provide the mechanisms for enforcing policies and ensuring reliable systems. It is up to the administrators and users to implement those mechanisms effectively. So that's the last part for our secondary storage management. So next topic is the OSI model. So OSI model and its 7 layers. The Open Systems Interconnection or the OSI model to the use and defines and used to understand how data is transferred from one computer to another in a computer network. In the most basic form, two computers connected to each other with LAN cables and connectors sharing data with the help of NICs forms a network. So the first layer is the application layer. So that is actually it's not the first layer, it's the seventh layer rather. So the application layer or the seventh layer of OSI model is the top layer that approaches protocols for application interaction with the network with a focus of with a focus on end user services. The application layer helps to facilitate process to process connections over internet protocol. This layer is what deals with protocols, web browsers, SNMP protocols, and HTTP protocols are examples of application layer systems. So next is the presentation layer. It is the sixth layer. It is the sixth layer of the OSI model, sometimes called the syntax layer. It is responsible for data encryption or decryption, character or string conversion, data compression, and graphic handling. So that's it for the presentation layer. Next is session layer. So session layer is the fifth layer. It controls the connections between multiple computers. The session layer tracks the dialogues between computers, which are also called sessions. It manages a session by initiating and opening and closing of sessions between end user application processes. This layer also controls single or multiple connections for each end user applications and directly communicates with both the presentation and the transport layer. So next is the fourth layer is the transport layer. So the transport layer, it is the one responsible for end-to-end communication over a network. It provides logical communication between application processes running on different hosts within a layered architecture of protocols and other network components. Also, this layer collects messages, segments from application and transmits them into the third layer. The segments are assembled into fully fledged messages and passed on to layer 7, which is the application layer. So next is the third layer, which is the network layer. It is a portion of online communication that allows for the connection and transfer of the data packets between different devices. It is the layer that provides data routing paths for network communication. Data is transferred to the receiving device in the form of packets via logical network paths in an ordered format controlled by the network layer. Logical connections set up data forwarding, routing, and delivery error reporting are the network layer's primary responsibilities. And we should keep that in mind because that that is the main goal or the main responsibility of the network layer. So next is the data link layer. The data link layer is the protocol layer in a program that handles the moving of data into and out of a physical link in a network. Data bits are encoded, decoded, and organized in data link layer. The data link layer has two sublayers, the logical link control or LLC and sublayer in the media access control or MAC address or MAC sublayer rather. So lastly is the physical layer. This is the first layer. So physical layer is the lowest layer of the OSI model. It deals with the bit level transmission between different devices and supports electrical or mechanical interfaces connecting to the physical medium for synchronized communication. This layer plays with most of the network's physical connections, wireless transmissions, cabling standard and types, connectors and types, network interface cards, and more so. Note that the physical layer does not deal with actual physical mediums such as the wires, the copper, the fibers, etc. Lastly, the final topic is the network platform. So, network platforms, according to Cubics, network-based platforms, by definition, a network-based platforms is a piece of technology. Is a piece of technology shared by many people, users with other members of a community to create mutually beneficial opportunities. Instead of simply being a tool to use with the four walls of an organization, network-based platforms help users find opportunities by connecting them with other users. Network while simultaneously fulfilling a function. The useless the usefulness of the platform snowballs as more and more members to join the network. This phenomenon is known as the network effect. So note that a network-based platform is a piece of technology that builds value by leveraging the network effect. So the examples of these network-based platforms are social media, Facebook, Twitter, Instagram, and all that. And ride sharing, Uber and Grab, yeah. Fitness tech, yeah. These are few examples of network-based platforms. So network-based platforms let users connect and collaborate with other stakeholders outside the four walls of their offices or homes. As more and more people become accustomed to network-based platforms like social media, companies are beginning to expect similar benefits from their business software, and companies demanding opportunities to collaborate with other stakeholders in their industry directly through the platforms they use every day. So, all in all, network-based platforms is truly revolutionizing in terms of business and how it helps people. So that's it. That's all. And as my report, thank you.